Hello students, last class we have seen some problems. Today in this class we'll continue the problems. Okay, so resistance, this is our sixth problem. This is the problem I have given you for homework in the last class. Okay, I hope you have done all. So if you have not done, still you can observe here, you can note down from this. See, note down the problem also and try to solve also by pausing the video, and if you cannot solve, then continue to watch the video. Okay. Resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. See, they have given you resistance of one metal wire whose length is 1 meter and it is at 20 degrees Celsius. If the diameter of the wire is 0.3 mm, they have given us diameter also. What will be the resistivity of the metal at that temperature? They have asked to finding the resistivity. Resistivity means rho. Using table 12.2 predict the material of the wire. So there is a table 12.2 which is giving you the resistivity of conductors, insulators and alloys. And find the resistivity first. What answer will come? We'll check it in the table 12.2 which material it would be. You got my point? So solution. So what is solution? Resistance of a metal wire of length 1 meter. What they have given, that has to be written first. This is the first and most important thing that is to be written while solving the problem. While solving the problem, please write down what is given there. Given resistance of a metal wire of length 1 meter. That means R they have given as 1 meter. R equal to 1 meter. That is resistance. Is 26 ohm. Sorry. Resistance they have given it as 26 ohm. Of length 1 meter. That means length they have given 1 meter. Okay. Length is 1 meter. Resistance is 26 ohm at 20 degrees Celsius. Temperature they have given. It is kept constant. No need to write the temperature. Even though if you want to write, keep it separate there. So if they have not changed the temperature, means it is okay. So R they have given, L they have given. Just we need to find out the resistivity. They have asked that what will be the resistivity of the metal at that temperature. Resistivity means rho. So we know that which formula should be used. We know that there are, I have written 4 formulas in the last class. You have to perfect those formulas. Okay, in that fourth formula says that R is equal to rho into L by A. Okay, but I want only rho. See, one thing we have to forget here, if the diameter of the wire is 0.3 mm, so diameter also they have given. So write down that one also. Diameter is 0.3 mm. Okay, diameter is 0.3 mm. So mm is not my SI unit. You have to keep everything in SI unit. That means D equal to 0.3 into mm means 10 to the power minus 3 meter. Okay, and I will turn it into, I will make this as 3. If I make 3 means I have to remove the point this side. I am removing the point right. When I remove the point right, it will become 10 to the power minus 4. Means I am increasing this value, means here I have to decrease the value. To balance, 0.3 is less value compared to 3. So I am making 0.3 as 3. That means what I did, I increased the value. Here I have to decrease the power. Minus 4. Don't get confused. Okay. Minus 4 is less than minus 3. When minus comes, bigger numbers becomes less. Smaller number becomes more. So minus 3 is greater than minus 4. Minus 4 is less. Here I increase the value. Here we have to decrease the value. So by 1. Because 1 point I moved this side. So we have to decrease it by 1. So d equal to 3 into 10 to the power minus 4 meter. So R is equal to rho into L by A. But I want rho because rho is asked here. Rho is resistivity or another one, or you can call it as specific resistance. So rho equal to R into A by L. So A will come this side, L will come this side. So A is at denominator on the RHS. When it comes this side, it will come in the numerator. L will come in the denominator. Okay. So rho equal to RA by L. Rho equal to RA by L. Now let us put these values. So rho equal to, so here A we have to change, we have to put the formula there. So what is A? See, that area of cross section is, that thickness we consider it as, area of cross section we consider always for circle. We consider, so this is a wire. If you say this front part, this will be, that is what you are seeing here. This, okay. I hope you are clear. This is wire. If you consider, this will be my area of cross section, thickness. That means we consider it as circle. So for circle, what is the area formula? Rho equal to R into, what is my area formula? What is area of circle? Pi R square. Okay. What is area of circle? Pi R square divided by L. But here they have not given us R. They have given us diameter. So convert R into diameter, it will become D by 2. Correct? If resistance is, if radius is 10 meter, then diameter will be 20 meter. Like that. So we have to put R in terms of D, means R equal to D by 2. D equal to 2R, whereas R equal to D by 2. Let us put that. Rho, it will become R into pi, so it is square, D by 2 square. That will directly I will write it as D square by 4. So the 4 I will join with L. So 4L. I hope you are clear. R pi kept it as it is, R square, small r square means D by 2 square. D by 2 square means D square divided by 2 square is 4. Okay. Here I will keep it as D by 2 square, that will become D square by 4. Yeah. So now rho equal to, what is my R? R is 26 into pi, you can keep it as 22 by 7 or 3.14. Whichever one you feel easy, you can keep like that. So let us keep it 22 by 7. 7 into 4. Here D square. D square is this much. 3 into 10 to the power minus 4 whole square. Into L. What is my L? L is here 1 meter. So it is 1. So please note down this. Rho equal to 26 into 22 into 3 into 10 to the power minus 4 whole square. Still we will continue. 26 into 22 squaring this. 3 square is 9. 10 to the power minus 4 square is 10 to the power minus 8. 7 into 4 is 28. Now from that directly you come this side. This part I will solve. Okay. 26 into 22 into 9 into 10 to the power minus 8 by 28. Okay. You have to solve this. You can solve by 26 into 22. Okay. Or else you can cancel here. 2 14s are, and very easily you can cancel this as 2 11s are. So 14 is there, 11 is there. Still we can cancel. 2 7s are, 2 13s are. 13 into 11 into 9. That is divided by 7 also. Okay. 13 into 11 into 9. So I will make it as 13 into 11 into 9 That is 13 into 99 it will become. So I will multiply 99 into 13, which will be easy. 13 nines are how much? 117. So 7 I will keep, 11 carry. 13 nines are again 117, 11, 128. 117 plus 11, 128. So my row will be 1287 into 10 to the power minus 8 divided by 7. So if you make this one again, what we will get for this? I hope you all are seeing 1287 divided by 7. What will be my answer? 7 ones are 7. I will get 5 here, or minus 7, 58. 7 eights are 56. So I will get 2 here. 2 is remaining, 27. Means 7 threes are 21. 6 will be there. If you take 0, 183.78 are 56. 183.8 I will get. 183.8 into 10 to the power minus 8. So, my dear students, it is always better or standard to keep the point after the first important number. Okay? After the first number, we have to keep the point. That means I will shift this point to this side. 183, I am making it as only 1.3. So 1.3 if I make, I am decreasing the value. Do you agree? 183 has been done to 1. 183 to 1 means I am decreasing the value. That means in power side I have to increase the value. That means it is minus 8. Increasing minus 8 means not minus 9. We have to decrease it. So we have to increase it. Minus 9 is a decrement. So minus 7 and minus 6, because I have moved 2 points left. Here also I have to increase it by 2 numbers. So minus 8, if 1 is increased, it becomes minus 7. If 2 is increased, it becomes minus 6. So 1.83 into 10 to the power minus 6 is the resistivity. What is the SI unit of resistivity? Please tell me. That is ohm meter. SI unit of resistivity is ohm meter. 1.83 into 10 to the power minus 6 ohm meter. Now we will check this in table 12.2. Okay, which is having 1.83 or 1.84 nearly. See here, it is 1.1838. Means we can consider it as 1.4 approximately, because 8 is here. 8 will be to the next. 38. 38 can be considered as 40 easily rather than 30. Okay. So 38 can be taken to the next number. So approximately that is 1.84 into 10 to the power minus 6. So where we will have 1.84 from table 12.2? You check it. It is there. If you are there in conductors last, please open the textbook. Okay, simply don't sit. Please note down. Keep the textbook aside and now open it. Page number 207, table 12.2. In the material list, conductors, at last, manganese is there. 1.84 into 10 to the power minus 6. Okay. So, this material is manganese. Here we can say that this metal wire is of manganese. This metal wire is manganese. This metal wire is manganese. Okay. Please note down this and we will move to the next question. I will explain it very quickly in 2 minutes. See, they have given us length of the wire, resistance of the wire, and diameter of the wire. They have asked the resistivity. Formula for resistivity is R equal to rho into L by A. So rho will come this side, it will become R into A by L. So here area of cross section we consider it as circle. So the formula of area of circle is pi r square. So R into pi r square, but we have given D here, not R. So convert R in terms of D. R is equal to D by 2. So if I put a D by 2 whole square here, okay, I will take you D by 2 whole square here, becomes D square by 4, right? So don't write this, just I am explaining this one. So it will become D square by 4 again. R pi D square by 4, L is already there. So rho into R pi D square by 4L. Okay. So next rho equal to 26 into 22 into 3 into 10 to the power minus 4 whole square, that is R pi D square. So 7 is there, 4 into 1. So if you take 26, 22, 9, 10 to the power minus 8, it is 7 4s are 28. So now cancelling, 2 14s are 2 11, 2 13s are 2 7s are 2 11s are. 13 into 11 into 9. 11 into 9 becomes 99. So I multiplied 19 into 13 here. Okay, don't write this, just you do other side, continue. So after this you will get 1287. 1287 into 10 to the power minus 8 by 7. You get 183.8 into 10 to the power minus 8. So you shift this one this side. 1.838 it will become. So we can make it as 1.84. So 1.84 into 10 to the power minus 6 ohm meter will be our answer. I hope everything is clear. Okay, we'll move to the next question. Okay, we'll move to the next question. So the next question is from your exercise page number 221, and the question number is 8, and our question is, okay, our question is 9th one, not 9th one, 7th one, sorry. We have solved 6 questions till this moment. So our question will be 7th one. Our question is of 7th. So what is that question? When a 12 volt battery is connected across an unknown resistor, when a 12 volt battery is connected across unknown resistor. When a 12 volt battery is connected across unknown resistor, there is a current of 2.5 milliampere in the circuit. There is a current of 2.5 milliampere in the circuit. There is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. Find the value of the, you can do this, resistance of the resistors. The resistance of resistor. See, it is very much easy problem. You can do it. Okay. See, it is very much easy. You can do this problem. Just pause the video now and try to solve. Pause the video. Try to solve this. If it is very easy, it is. Just note down the problem. Pause the video. Try to solve this problem. Okay. Very easy. 12 volt battery is given, means V is given. They have given the current, I have given, they have just asked R. Just Ohm's law you can apply, you will get the answer. V equal to IR. So asked R means R equal to V by I, 12 by 2.5. So only it is in milliampere, convert it into amperes. Do it by pausing the video and I will solve it. Okay, now we'll see the answer. Solution. When a 12 volt battery is connected across unknown resistor, so given, what is given here? V equal to 12 volt. Battery is connected across unknown resistor. Resistor we don't know. Current they have given. I equal to 2.5 milliampere. So milli in the sense, remember milli equal to 10 to the power minus 3. Milli in the sense 10 to the power minus 3. Micro means 10 to the power minus 6. The small m is milli. Micro is represented like this, mu. Okay. So this small m is milli. Milli in the sense 10 to the power minus 3. So I will becomes 2.5 into 10 to the power minus 3 amperes. Always keep everything in SI units. Milliampere is not my SI unit. My SI unit is amperes. So I will keep it in SI unit. V I just need to find out what is R. Okay. V is there, I is there, R. What is the formula connecting V I R? Ohm's law. V equal to IR. So we know that, or using Ohm's law. Okay, using Ohm's law, V equal to IR and R becomes R equal to V by I. So R becomes V by I means R is equal to how much? 12. I means 2.5 into 10 to the power minus 3. So I will make 12 divided by 2.5. 10 to the power minus 3 will be taken upper side. So here I will make 12 divided by 2.5. So how to make 12 divided by 2.5? We just remove this point and add a 0 here. Okay, I removing this point means multiplying with 10 and I have to multiply this one with also 10. 2.5 became 25, 12 became 120. Now we'll do the problem. 25 4s are 100, 120, 100 gone, 20 is remaining. We'll take point, we'll put 0, 25 8s are 200. So 4.8 is my answer. So here R is equal to 4.8. This I have not considered. It is still 10 to the power minus 3. I will take this in upper. So R is equal to 4.8 into 10 to the power 3 ohms. See here. When it is in denominator, it is 10 to the power minus 3. When I will take it in the numerator, the power sign will change. Okay. If it is in minus, it will become plus. If it is in plus, it will become minus. 10 to the power minus 3 become 10 to the power plus 3. So R is equal to 4.8 into 10 to the power 3 ohm. So finally you can leave it here also, or you can add 10 to the power 3 means we can call it as kilo. Right? Kilo. For 10 to the power 3 means 1000. 10 into 10 into 10. How much you can? 10 tens are 100, 100 tens is 1000. So 10 to the power 3 means it is 1000. 1000 we call it as K, kilo. Okay. So R equal to 4.8 kilo ohm. This is our final answer. Or you can leave it here. It is a very easy question. Okay, you can do it very easy. R is equal to V by I. This is the formula. 4 formulas you have to remember till this moment. Q is equal to I is equal to Q by T. First formula. Second formula, potential difference. V equal to W by Q. Third formula, V equal to IR. Ohm's law. Fourth formula, R equal to rho into L by A. That is our resistance formula. Resistance equal to resistivity into length divided by area of cross section. I hope this much is clear with this problem. Okay. So now just note down this problem, and there are some questions in this. Just I will discuss and I will wind up this session. There are questions in page number 209. Okay, questions of text they are there. So I will just discuss those. On what factors does the resistance of a conductor depend? You already know this. Resistance of a conductor depends on what factors? R equal to rho into L by, in that only it is there. L, A and nature of the material. That means resistance of a conductor depends on length of the conductor, area of cross section of the conductor and nature of the material. These 3 points we have to remember. And fourth one, second question there in the only. Will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source wire? Is current flow more in thick wire or thin wire? So if the wire is thick means area of cross section is more. Area of cross section more means resistance is less. That means there will be more current. So in thick wire there is more current compared to thin wire. Okay. So third and fourth they are there. I will give you as homework. Okay. If you don't do that, if you don't understand that, you will see in the next class or you can contact me notes. But you have to do that. Okay. Try to do that. Third and fourth. Fifth one I will do. Fifth one we will discuss. Use the data in table 12.2 to answer the following. Please open this book and read them. Which among iron and mercury is a better conductor? Which material is best conductor? See, iron and mercury will use table 12.2. Iron is having 10 into 10 to the power minus 8 resistivity and nickel is having, mercury is having 94 into 10 to the power minus 8. Iron and mercury, iron 10 into 10.0 into 10 to the power minus 8 is its resistivity. Mercury is 94 into 10 to the power minus 8 is its resistivity. Whose resistivity is more, it will not conduct the electricity. That means if the resistivity is less, that is a good conductor. Out of these two, which is having less resistivity? So iron is having less resistivity. That means iron is a better conductor compared to mercury. Okay. And another question is there, which material is best conductor? So which is having the least resistivity? So much least resistivity in this table. That is first one, silver, 1.60 into 10 to the power minus 8 ohm meter. So silver is the best conductor. Okay. So you third question and fourth question you try in your home. Okay. If you have not got the answer, that I will give you as homework. If you have not got the answer, please contact me through WhatsApp or mobile number. So this is regarding your electricity problems till this moment. Okay. And next we will come across resistors in series and resistors in parallel. Some problems in resistors in series and resistors in parallel, and heating effect of electric current, power. Okay, electric power we all will come to know in the upcoming classes. So please do study well and concentrate on these classes. Okay, you have to attend all the classes and note down all the classes. Please write down the notes. Whatever I will write it on the board while watching. Take a book, rough book or whatever book you take and write down the notes. Okay, and try to solve maximum numericals. Okay, so we'll continue our electricity class in the next class.